In this part of the video, we'll be addressing running large language models on CPU-based instance and referencing, so without having a GPU. Uh, there are several serving runtimes that come with Red Hat OpenShift AI out of the box that support this. So one of these is the OpenVINO model server. Sorry, this one, the single model, and also the TGS standalone serving runtime for Kserve. At the time of creating this video, the LLM is not offered as an option in out of the box with Red Hat OpenShift AI. However, this is coming shortly. Um, Now, for VLLM, there is the option to go with CPU and or with GPU. For CPU, it is required to have, if you look at the nodes, at the machines, you need to have, a node that has AVX 512 instruction set available, and M5 on the AWS cloud is part of this family. So you can go to compute on AWS and check on the instance types, and you need to see that this instruction set is available on the CPU. Then you can deploy VLM on CPU. I have created in the GitHub repo the details how to compile from source uh, uh, the container, but I also published a compiled option over here, so you can use this deployment file directly from here. So if we go to LLM on OCP, and if we go to the serving runtimes and we go to CPU serving for the VLM CPU, I have the container file that explains you how you can create a container file for this, and also the YAML file that I used here for deployment. Now, for the container file, uh, today there is a bug on how the installation proceeds. So the egg file that is created out of the uh, compiling process, it's not properly loaded in the container file for some reason. I don't know why. However, you need to or you can fix this by going around it and actually declaring the work directory exactly where the egg file is. So obviously the first time you do this, it will fail because you don't know where the name of the egg file will be, because this also depends on the latest version of the VLLM that you'll be installing. Or if you know that in advance, then you can follow this template path over here and just make sure that it matches the description of the compiled egg, and then the entry point will actually start up in the right location so that everything loads up properly. Yeah, so and the same thing I have here for Olama. Now I have the Olama YAML file that can be used for deployment, and the compiled container is available in the Red Hat AI Services business unit on the Quay IO registry. And the idea about using Olama, so this is used a little bit differently from the other model servers, because the model needs to actually be transformed to be compatible with the Olama serving internals. And there is a procedure that you can use to do that. So it's described in the Olama docs. So how you can import a model that has to meet certain prerequisites in order to be importable. And once you import it, then you can also publish it and have it available in the models library that you can use. So right now, as I was saying, the M5 here is part of this family, so we can use the deployment for the VLLM CPU based, and I also installed the Olama. For the setup, like when the deployment, you do the deployment inside the data science project. So for example, here we have the LLM test. Now this UI uses version 2.9 of the Red Hat OpenShift AI, so it's a little bit different compared to the previous videos that I made in this series, but the functionality is the same. So it's the same. It's just the UI; it's a little bit different. So I have the Mistral 7B instruct deployed here. So if you look at this, as the CPU deployment, there's no accelerator enabled. And if I also look to see like where is actually running, if I'm going to workloads, and this is in the LM test, this is my running pod. So, and the pod is running on this node, and this node is the M5 X large. Now, to ensure that your deployment actually happens on this node, you need to uh, provide the instructions for OpenShift to deploy it over there. So in the nodes here, you can edit the labels and add a new label. In my case, I added this label here, VLM-node equals CPU. You can add anything you want, but this is what I chose. And then this exact label needs to be part in the serving runtime definition, so the VLM.CPU. Look here, so it's the node selector VLM node CPU. So this, when you deploy it using this set, then this instructs Kubernetes to actually deploy the pod on the node that has this label. Like I said, you need to ensure that wherever this is deployed has the supported instruction set required by VLM. So once you do this, deployment proceeds as normal as in the other deployments, right? So you go here to the models, you say deploy model, and then you fill in all the information. And same, you select the path where your bucket is, and then the folder where your model is, and then click deploy. And eventually you'll get something like this with the URL that you can then use. Now, if you look at the pod itself, it happens in the same pattern, right? So this is the pod. If we look at the logs, so we have the storage initializer that will connect to that bucket and download the model, and then it will be served in the kserve container. And the test, so basically the inference URL you just provide there. The rest of the uh, file that I used for the GPU based setting stays the same. There's no other changes here, and you run it. The difference will be that it will run slightly slower. So we can see here that it takes a little bit of time before the model starts replying, but after that the streaming, the pace of the response that's being returned, it's fairly decent. So you need to account for this wait time. Now let's deploy the Olama one and see how that behaves. For Olama, there is another particular thing that you need to know about is that, as I explained to you, you need to load the model from the library from here, right? So this means that, for example, when we deploy the model, we'll get an inference URL for it, and we'll get also an instruction set like how we can operate with that serving runtime. So we'll need to pull a model from somewhere. So we pull the model Mistral, right? Because Mistral is available here in the library. So it's actually right here. So we need to pull it before we serve it. And then we have the setup. Now, in addition to Olama, we also need to do this two instruction set that weren't necessary for the VLLM. And then the conversation follows as the other one. And you see here that it's quite faster. Um, and so you can see which model, I mean, which type of deployment you prefer. But keep in mind that if you use Olama, you want to do a specialized model, you need to do the import process that has some additional steps on top of what you do. Now, because of this import process, obviously, when you do the deployment here, you cannot or you shouldn't upload the model, right? Because it's not necessary, because that's not how it takes the model, right? So what you do is that we go to the project. We have this other project where we deploy the model, and we're gonna use it, what we called it here. this is the model. So let's use this here. We select the Ollama CPU, select the framework, which is any, just one replica to deploy, do a custom, 4 and 6 here, 24, 32, may not need so much, but in any case, now select the name LLM bucket, and like I said, we need to provide here something, right? But we don't need to provide the model. So for that purpose, you can actually create an empty file and just upload the bucket into a folder, because we need a folder, and it's called ollama-empty. So here we will provide ollama-empty, just to make sure it's the right. So we can see that we have the empty file over there, ollama-empty. All right. Let's say we expose it like that, and we just click deploy. Now this will take a while, so if you go now to the deployments here, we go to the test project, you see that getting the we go to the logs, the storage initializer is just copy that empty file, and then it initializes the KCF container, and it also gives us the list of the operations that we can use to interact with it. Okay, so now we can also see that this one has gone to a node that has the AVX2, right? So it doesn't need that AVX512. So AVX2, it's AVX256 actually. And if you look at where the pod is, right? So it's in a different node, and this is an M6A4X large, right? So for Ollama, you don't need that instruction set that I was mentioning earlier. Right, so here it is. Now it's running, and if we look at the, just to make sure that this is the right URL, I'm gonna paste it here. And looks exactly the same, so I didn't make any mistakes once I retested this. All right, and we're gonna run all of this again. So we're gonna restart the kernel, and actually we don't need to restart it. We just need to run all the cells. Run all cells. Right, so we got the certificate, we ran through all of that. Now it's pulling down the model, so it'll take a while. There's a newly initialized pod. Okay, so it did that. The prompt is initialized, so here is the first request, and it goes through. The response when we use the VLLM, it's similar to this one. It's just that it takes a little bit more time before it actually starts providing the response back over here. But the pace of the streaming of the response is the same. So you see the request was completed in 28 seconds as opposed to 44 seconds. Okay, so, and the second question, is there a river? Started answering at 18 seconds as opposed to 37 seconds. Then we next one, get the response. So the time here, it has both the time taken before the model actually compiles the response and gives it back and streams back the response, right? So we need to take into account these two factors. Now the streaming here, like I said, it's similar. I don't know if it's exactly the same speed, but the comparison here is not exactly like apples to apples, uh, but I mean it's close enough, just to give you an idea. Okay, so that's it. for this part. You have the options to go with serving runtimes that are out of the box or add additional ones. Uh, and for VLM, it's very robust and it's very good, and it has a lot of support and integration possibilities with LangChain. You can add any models without needing to touch them. So you can perform transfer learning and just use that model and upload it to your bucket. Whereas opposed to Olama, you need to actually go through the process of transforming that and publish it in a repository. There is also the possibility that you incorporate the model in the or you upload it on the PVC afterwards, or create a PVC where you upload the model or something like that, that can be attached to the pod where the Olama server is running, and then invoke one of the commands from here. Where was it? Pods, logs. Right. So one of the commands from here to be able to basically start to serve it. And yeah, actually, I don't think there's a command for that. Pull, generate, chat, embeddings, create, push, copy, show, blog. Yeah. So in any case, you can pull it from a repository and then work with that from there. That's it, as I said, for the CPU-based deployment. I hope you enjoyed it.